So in this video, we're going to learn about what is known as the limiting reactant. So we'll learn that when we are performing chemical reactions, we don't always have our masses of reactants balanced. So one of them will always be in limits. So it'll be in reduced quantities and it will limit the reaction. It'll prevent more of the product from being produced. No matter how much of the other reactant you add, it's always going to limit the reaction. So remember, when we read a balanced chemical equation, we see that no reactants are left over. In a balanced chemical equation, it tells us that precise amounts react to form precise products. But in real life, we can't be that precise. There's usually reactants left over of one of the types. So I thought we'd pause and do a thought lab from our old chemistry textbook called The Limiting Item. So it says, imagine that you're in the business of producing cars. A simplified equation for making a car is one car body plus 4 wheels plus 2 wiper blades makes one car. So the question is, assume that you have 35 car bodies, 120 wheels, 150 wiper blades in your factory. How many complete cars can you make? So we have to go and look at our supply and what we need for each one. So we only need one car body for each car, so we can make 35 cars with the car bodies. 120 wheels, but we need 4 wheels per car. So we need to divide that by 4. So we can make 30 cars from the wheels. And then 150 wiper blades, if we divide that by 2, because you need 2 per car, we can get 75 cars from the wiper blades. So it says, the next question asks, which item limits the number of complete cars that you can make? Stated in another way, which item will run out first? Well, it will be the wheels, because we can only make 30 cars from the wheels. And which items are present in excess amounts? So the bodies, a car body, and the wipers are the things that we have excess of. And how much of each excess item remains after the reaction? So in the bodies, we could have made 35. We can only make 30 cars, so there's going to be 5 bodies left over. And 75 minus 30, we'll have 45 blades. Pairs. And so that would actually be 90 individual blades. Does the amount that an item is in excess affect the quantity of the product that is made? No, because whichever one limits is going to be the one that stops the reaction. And then the next question says, there's fewer car bodies than wheels and wiper blades. Explain why car bodies are not the limiting item in spite of being present in the smallest amount. Well, that has to do with our balanced chemical equation. You have a coefficient of 1 for the car body, but there's a coefficient of 4 and 2 for the other two. So you need the lowest quantity of car bodies to make your complete car than in comparison to wheels and wiper blades. So we'll define the 2 terms that we will be using. So the first one is the limiting reactant. So that's the reactant that's completely used up in a reaction. When it's used up, the reaction will stop. So if you look here, in this image, it's showing that before the reaction we had 10 hydrogens and 7 oxygens, and they bump into each other and eventually have some effective collisions and create water molecules. But the oxygen was in excess. So we actually, in the end, have 10 water molecules and 2 oxygen molecules left over. So not all of the oxygen was able to react because it didn't have any hydrogen to react with. So in this equation, hydrogen was the limiting reactant. The excess reactant is the one that has some left over after the reaction has stopped. So in the same example, we had 10 hydrogens and 7 oxygens. We reacted all of the hydrogen to produce water, but we had 2 oxygens left over. So to find the limiting reactants, we can find out how much product can be made from each reactant. So we'll take a look at the 2 values of reactants, or 3, depending on how many reactants are involved, and then we can decide how much product they each be able to make, and then from that, whichever one makes the least product will be your limiting reactant. So we'll work through an example and demonstrate how this will work. So if 4.87 grams of lithium nitride reacts with 5.80 grams of water to make lithium hydroxide and ammonia, find the limiting reactant. So the first thing, as always, we need to make sure we have balanced our chemical reaction. So we have Li3N. So there's 3 lithiums, but there's only 1 here. So we'll put a 3 here and check out our balance. Now we've made 3 oxygens, but we only have 1 over here, so we'll need to put a 3 here. 3 times 2 equals 6. We have 6 hydrogens, and then 3 plus 3, so we have 6. So our chemical equation is balanced. So we need a 3 in front of water and a 3 in front of the lithium hydroxide. So again, we'll solve using the table. So remember, we divide down and we multiply up, but we're not actually finding products. This time we're going to be dividing down for both sides. Remember, from our balanced chemical equation, there was a 3 in front of the water. You need 3 water molecules to react with each lithium nitride. And we'll put down the information that we know. So we know that we had 4.87 grams of lithium nitride. We need to find the molar mass. So we need the molar mass of lithium times 3 plus the molar mass of nitrogen. So that is equal to 34.83 grams per mole. Now we'll divide the mass divided by the molar mass. So we get 0.140 moles. And we divide by the coefficient. This time, so divide by 1. This time we're not carrying that up anywhere because we don't know which one's the limiting reactant yet. So we just leave it there. Then for water, we'll do the same thing. So we were told that we had 5.80 grams of water. And then the molar mass of water is equal to 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. So that's 18.02 grams per mole. And then we get 0.322 moles. So right now it looks like water is in excess. We actually have more if you look at the mole column, but we have to remember about the coefficient. So we need to divide by 3 because we need 3 water molecules for every 1 lithium nitride. So it actually is equal to 0.107 moles. So in this example, the water is the limiting reactant. So if you were asked which one is the limiting reactant, in this case it's water. Now sometimes you'll be asked to go the step further. So figure out what the limiting reactant is and then calculate the mass of the product. So in this one, and you have to be careful by the wording of the question because it's not asking you to actually find the limiting reactant. It just gives you 2 quantities of the reactants, and then it asks you what mass of the product is produced. So you need to realize when you see the 2 values for reactants, you're going to need to figure which one is the limiting, which one's in excess, and then use the limiting reactant to predict the mass of the product. So let's read the example. So We have a 1.00 gram piece of white phosphorus burned in 15.0 grams of oxygen gas to form tetraphosphorus dicoxide. What mass of P4O10 is produced? So we need to find the balanced chemical equation. So the phosphoruses balance out 4 and 4. We have 10 oxygens on the product side, but only 2 on the reactant side. But we know that we can put a 5 here, and then that is balanced. So we just need a 5 in front of oxygen, and the rest is left as is. So we have our tables set up. So for the reactants, we'll divide down. And then we'll figure out which one is limiting, and then we'll multiply up for our product. So before we get started, I always like to put the coefficients in. So 5 oxygen, and the rest are just coefficients of 1. So now we'll put our values in. So our mass of P4 was 1.00 grams. And then our mass of oxygen was 15.0 grams. Our molar mass for P4 is 4 times the molar mass of phosphorus, so 123.88 grams per mole. So we'll figure out 0, that will be 1 divided by 123.88 is 0.00807 moles, and we divide by our coefficient, so 0.00807 moles, because there was just a coefficient of 1. So then for oxygen, we had 15 grams, and the molar mass of an oxygen molecule is 2 times 16, so 32.00 grams per mole. So 15 divided by 32 is 0.46875. Already we can see, and I kind of predicted this already, that we're going to have more than enough oxygen in comparison. So we still need to divide by the coefficient, but we're still not going to get a value as small as the molar value of P4. So it's equal to 0.09375 moles. So this one's the limiting. So we're going to carry this over. So we've already divided by 1. We would multiply by the coefficient of 1. So the number of moles of P4O10 is 0.00807. Now we need to find the molar mass. So the molar mass of P4, so 4 times the molar mass of phosphorus, plus 10 times the molar mass of oxygen. So that is equivalent to 283.88 grams per mole. And then we multiply that by our molar amount, and we get a mass of 2.29 grams. So just to make a note here, we often, when we do reactions involving combustion, we usually attempt to have excess oxygen. Might not always be the case. If you don't have excess oxygen and oxygen's the limiting reactant, you can end up with products of reaction that are actually quite dangerous. So if you were burning a fuel and you didn't have enough oxygen, instead of making carbon dioxide and water as your products, you would make some carbon monoxide and some carbon, and carbon monoxide is a highly deadly gas. So usually we try to have excess oxygen in our reactions involving combustion.